Number 9. 2 kilogram cannonball embeds itself in a block of wood that's hung from a rope. The combined mass rises 0.2 meters in elevation. Determine the mass of the block of wood. This is very similar to other problems we've worked. We did this in recitation. Couple parts to this problem. Embeds. Okay, so the fact that it embeds itself, this is a collision. So we're going to use conservation of momentum. Okay, and then when it raises 2 meters in elevation, we're going to use conservation of energy to determine, compare those two states. So conservation momentum says that the mass of the cannonball times the velocity of the cannonball plus the mass of the wood times the velocity of the wood before the collision, and these things combine, so they embed. So this is a perfectly inelastic, so I'll go ahead and write it as just, they'll have the same final velocity, mass of the wood. Alright, so we know the mass of the cannonball, we know the velocities before, we don't know the velocity afterwards. Okay, but we do know the fact that it raises 2 meters in elevation. So let's come back to our conservation momentum, because right now we have two unknowns, the mass of the wood and the velocity. So conservation of energy is just going to give us the initial kinetic energy is going to be equal to the final potential energy. Okay, if I want to draw it out, I'll have the V prime here, and then as it swings up, I'll have V equals 0 at its highest point. I'll have some H right there. I'll use this as a datum. So initial kinetic energy, the things at the datum we set, it's moving, is equal to final gravitational potential energy. Alright, so this equation says 1/2 the mass of the wood plus the mass of the cannonball times V prime squared, which that is that V prime, is equal to the mass of the wood plus the mass of the cannonball times G just write it as GH. Alright, so in this equation we again have two unknowns, the final velocity and the mass of the wood plus the mass of the cannonball. Okay, let's go ahead and let's see, this initial velocity of the wood is 0, so that drops out. So to make our writing a little bit simpler, let's just call this a total mass. So that would be total mass and that would be total mass. Okay. So in this equation I'm going to have 2 is the mass of the cannonball and 80 is the velocity, is equal to V prime mt. Okay, and let's see, 1/2 mt V prime squared is equal to mt times 9.81 times 0.2. Okay, so I have two equations, conservation of energy, conservation of mass. I can then solve them. I'm looking for the mass of the woods. That's going to come from mass total. So I'll probably solve this one for V prime. It's 160 over MT. Okay. So then I've sort of run out of room, but I'll have 1/2 MT times 160 over MT, and we'll write that as squared and squared is equal to MT 9.81 times 2. Alright, so that one I can solve. In fact, this MT cancel out, and it looks like I can do my algebra right. When I have 0.5 times 160 squared is that term divided by 9.81 divided by 0.2. Okay, so that's taking all my numbers to this side. I multiply MT squared over here, so I will take the square root of that answer, and I'll get 80.77. Alright, so that's the total mass. So the mass of the wood is equal to MT minus MC is equal to 78.77, or 78.